Welcome back, scholars. We're making our next video talking about trapezoids and kites, guest starring A2. A2, give yourselves a round of applause. Nice. Very good. All right. Let's get right into it. Talking about trapezoids. A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Exactly one pair of opposite sides parallel. Okay. We call those parallel sides the bases, and the non-parallel sides are called the legs. So let's go ahead and label our picture up here. We got a base on the top, we got a base on the bottom. Those are our parallel sides. And our non-parallel sides are our legs. Okay. We can have a special kind of trapezoid, an isosceles trapezoid. You guys remember what an isosceles triangle was? Yep, had how many pairs of, or how many sides were congruent in an isosceles triangle? 2. It'll be the same situation here in this trapezoid. If a trapezoid is isosceles, then each pair of the base angles is congruent. Congruent. So go ahead and mark those in your diagram. Those base angles are congruent. But there's 2 bases in a trapezoid, so both of those pairs of base angles are congruent, the top ones and the bottom ones. All right, this next one, if a trapezoid has a pair of congruent base angles, then it is called an isosceles trapezoid. Isosceles trapezoid. And a trapezoid is isosceles if and only if its diagonals are congruent. So let's draw those in. That was a pretty good line for me. Thanks. Ooh, not bad. Not the best. Those diagonals are congruent. So segment AC congruent to segment BD. Thank you very much. Okay. So be careful, a trapezoid is not a parallelogram. It only has one pair of opposite sides parallel, whereas a parallelogram has both pairs of opposite sides parallel. So all the things that are true about parallelograms are not necessarily true about trapezoids. All right, let's do some examples. We're going to find all the angle measures in A, B, C, D in both of these places. They give us 2 angles, 132, and what's that square in the corner mean, A2? 90 degrees. So we're going to use our parallel lines here. Got parallel lines. What kind of angles are angle B and angle C? Are they same side interior, alternate exterior, alternate interior, or alternate... or corresponding, sorry. Same side interior. What do we know about same side interior angles? No, they're not the same. They equal 180. They're supplementary. So that's going to be true for B and C and A and D. If C is a right angle and B and C are supplementary, what do we know about B? It's also a right angle. 90 plus 90, that's the only way to make 180. So the same concept is true with A and D. They're same side interior. They add to 180. Let's do that. 132 plus the measure of angle D equals 180 degrees. Take 20 seconds trying to solve that for angle D. Bing, bing, bing. Bing, bing, bing. 180 minus 132, I'm going with 48 degrees, is that correct?
Yeah.
All right. 48 degrees. All right, 1B, it's a special kind of trapezoid. What special kind of trapezoid is this? Yell it out, A2.
Rhombus.
It's not a rhombus. It's an isosceles trapezoid. Very nice. See, those legs are congruent to each other, right? Those legs are congruent. Those legs are congruent, so that means the base angles are congruent. So C is congruent to D. So what's the measure of angle D? 77 degrees. And angle A will be congruent to angle B. So we could either add all of these up to equal how much, since it's a quadrilateral? It would add equal to 360. So we could do, again, because these are going to be the exact same number. A and B will be the same number. I can call them X. So we could do X plus 77 plus 77 equals 180, or sorry, 360. 360. Could do that. Or you could find the supplement to 77. 77 plus X equals 180. Either of those equations will give you the correct answer. This one looks like less work to me, so I'm going to say that guy. So X equals 103. All right, 103 degrees. Okay, cool. Cruising right along. Number 2, draw trapezoid JKLM with JK parallel to LM. So that means those are our bases. Okay, let's draw our picture. It doesn't tell us that's isosceles, so those sides don't have to equal each other. Just tells us that JK is going to be parallel to LM. So those are our bases. All right, let's do a little matching action. Segment JK and ML are the what? Yell it out, A2. Those are our bases, or segments. Those are our bases. All right, that's a base. That's a base. How about MJ and KL? Good, those are legs. How about ML and KL? They're not diagonals. ML and KL. Oh yeah, they're sides that are right next to each other. Very good. Consecutive sides. How about angle K and angle M? Those are definitely opposite angles. Oh yeah. Good job. How about segment JL and KM? Good. Those would be diagonals if we drew those in. So I guess angle L and angle M are base angles. Nicely done. All right, cruising right along. Y'all are doing great. The mid-segment of a trapezoid. Mid-segment of a trapezoid connects the midpoints of each leg of a trapezoid. Connects the midpoints of the trapezoid legs. Okay, so that means this is a midpoint of AB, and this is our midpoint of CD, our mid-segment, connects those two. So there's some interesting information about mid-segments of trapezoids. Each mid-segment of a trapezoid is parallel to each base. So these are all 3 parallel. And the length of this mid-segment is half the sum of the length of the bases. It's half the sum of the lengths of the bases. So it's halfway in between, perfectly halfway in between the length of each base. So if we look at this example here, find the length of the mid-segment. The length of MP is half the sum of the 2 bases. I'm going to write out what I just said. MP is 1/2 the sum of NO plus LQ. Some of you already figured this out. It's half of 14 plus 16. 14 plus 16 is how much? 30. What's half of 30? 15. Just like Mr. Sims, or Smith, Mr. Keith said. I apologize. It's also the number halfway between 14 and 16. Perfectly halfway in between there. Right? Okay, now this one's tougher, because now they give us the mid-segment. 8 is halfway between 11 and what number? 8 is halfway between 11 plus some number. We could solve this equation, or we could do the easier way. Yeah. 11 minus what is 8? 11 minus what is 8? So we could do that same thing. 11 minus 3 is 8. Minus 3 again. What's x going to equal? 5. You could solve this equation for x, or the simpler way, figure out how to move from one base to the mid-segment, and the mid-segment to the other base. All right, let's move on to a kite. A kite is actually a very special geometry figure. A kite has consecutive sides congruent. So it's a quadrilateral that has consecutive sides congruent. Consecutive sides congruent, but its opposite sides are not congruent. Opposite sides are not congruent. Okay, a couple of theorems about kites. If a quadrilateral is a kite, then its diagonals are perpendicular. The diagonals are perpendicular. Who else had perpendicular diagonals? A rhombus had diagonal perpendiculars. So who else has what diagonal perpendiculars? Yeah, a square. Rectangles are not. Rectangles' diagonals are congruent, though. Very good. And the next one, if a quadrilateral is a kite, then exactly one pair of opposite sides are congruent. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So only one pair are congruent. Exactly one pair of opposite angles are congruent. Because opposite angles are congruent. Okay, you're going to finish this last page using your notes for IP. Let's give a big round of applause for my A2 class. Thank you guys for being here, you beautiful humans. I love you so much.